All right, everyone. So here is our last lesson of the week. We are going to be in Chapter 2, Section 6. And we're going to talk about modeling situations with equations. This is one that students either really like or really don't, and I'll give you that warning now because they're really open-ended. There's a lot of different ways to solve these problems. I'm going to give you some tools and tricks, but if you have a way that solves it and you check that back in the book and it works, your method probably does work. There's a lot of different ways to do these problems. So let's get our notes all ready and let's get started. So for a lot of these, you're going to have problems that are what I like to think of as geometry problems. You might also have some physics problems. So for number 1, you have 140 feet of fencing for a rectangular garden. Write a function of the area of the garden in terms of its width. So it's like, oh, I've got a rectangle and an area. And I'm going to use one of the methods I strongly recommend for these, which is just to start with the formula. So if it's volume, surface area, perimeter, anything like that, a really good place to find all these different formula are the internet, or honestly your planner has most of them. So you can Google a lot of these. Hopefully you don't have to Google the area of a rectangular shape, but you know what? Go for it. Believe in yourself. So I'm always going to start with my formula. So in this case, A is equal to length times width. If it's a rectangle, that's the formula for area of a rectangle. And now here we can see it says in terms of its width W. And what that tells us is that W is fine here, but the length here we want to replace in terms of W. Now, we're going to use the other fact that we know about W in order to do this. So then you're looking, okay, I don't know how to replace that, but what I do see here is I see that I've got 140 feet of fencing. Now, if you think about fencing for a second, this means that it's the perimeter of a rectangle. So I'm going to use another formula. In this case, this would be 2L plus 2 width would be the perimeter of a rectangle. And so this is, again, why students don't tend to like these sometimes. It's because you have to do that sort of logical step of realizing, oh, we're talking about fencing. That means we're talking about perimeters. In this case, we'll say, all right, we want to replace this one, which means that you want to solve for L so that you can plug it in. So we're going to solve for L. We have perimeter is 140, which is equal to 2L plus 2W in this case. Subtract 2W from both sides, so 140 is equal, minus 2W is equal to 2L, and divide everything by 2, which says 70 minus the width is equal to the length. Once we have that variable solved for, and again, the way that we know this is that the one we want to replace, the one that's not what we're looking for, is the one we want to solve for. Then we plug that back in. So in this case, we say that the area is equal to length, which is, remember to use parentheses, 70 minus W times W. And this would be the factored form. We're going to always simplify when we can. And so this would be 70W minus W squared using the distributive property. So that's our function. Now, the helpful thing of writing a function versus just trying to solve right away is then we can find other things, like what is the maximum of the garden? Well, if my formula is, I might even rewrite it as negative W squared plus 70W plus 0, and I'm writing it in this way specifically because we're asking about the maximum of a quadratic. So that just means what is the vertex of this parabola? So I'm going to use the formulas that we talked about in previous lessons, that negative b over 2a, and I'm going to plug that in here, where a is negative 1 and b is 70. So our formula is that width of the maximum area is negative 70 over 2 times negative 1, which means that the width at the maximum is 35. The maximum area is then negative 35 squared plus 70 times 35. I'm just plugging it into the formula that we had before. And I used a calculator for this. I think that that's fair. You could do it by hand. It would just take a little bit longer. Is 1,225 feet, and it's squared like so. Now, we did talk in our last lesson about finding the maximum using a calculator, but you don't need to. For this one, for number 2, the manufacturer wants to make a metal can that holds a liter, which is 1,000 centimeters cubed. Write an equation for the surface area in terms of the radius r. So again, in this case, we're going to be looking at holding a liter, and it's a metal can. And this is the sort of interpretation, again, that not every student thinks is a lot of fun. Metal cans are cylinders, so that's how we know what we're talking about. And then liter is the volume. So the formulas that we're going to start with are volume of a cylinder, which is pi r squared h, and the surface area, which is the thing we're actually trying to write the equation for here, is 2 pi r squared plus 2 pi r h. Now, we're going to end up with this surface area function as our final answer because that's what we want to write the equation for, but we want it to be only in terms of r, which means that h is what we need to replace, and therefore in the other one, this is what we have to solve for. Now, v, we're given the volume is 1,000, so pi times r squared. H, I want to get h by itself, so 1,000 over pi r squared. And that's just going to give us what we want to replace. We can leave it like that. So now is the time for our substitution, and we're going to plug it back into the surface area formula. So surface area is equal to 2 pi r squared plus 2 pi r, replacing h with 1,000 over pi r squared. Now, again, this is great. We do want to make sure that we're simplifying, especially with this multiplied fraction here. We can divide out a pi from the numerator and denominator as well as an r, and we would end up then with surface area is equal to 2 pi r squared plus 2 times 1,000, so 2,000 over r. It might be one way. We might also simplify it down into one single fraction, multiply both sides by r, so 2 pi r cubed plus 2,000 over r. Now, if you wanted to find the maximum and minimum of this one, you would definitely need a calculator because we are not looking at a quadratic. However, all you need to do here is write the equation. Please let me know what questions you have in the comments or set up a Zoom session. I look forward to hearing from you all.